Okay, we are live. Close that. How's it going? We got some stuff to do today. Oops. A lot of stuff to do today, actually. So I started working on this mini grid env yesterday. I think we're going to finish that, and then we have a couple other things as well. Very basic. Oops. But we got to implement a few little mechanics here. I kind of just wanted to do this to have like a one-to-one comparison with an existing thing in the field. But let me just, to jog my memory and also to get us set up for the day here, let me just show what this is going to be. So there's this mini grid environment. It's kind of silly how much RL is done on this because it's like, it's a really simple suite of environments, and the reasons that the reasons that make it hard are very arbitrary and misguided. Essentially, like, you can just keep making the environment bigger, and like me looking at this, I can see, oh, the goal is here, I should go there. But if you learn this tabula rasa, that's basically impossible to learn if you make it big enough. So I'm not going to do anything about that fundamentally, but I figure that Puffer's just fast enough that it shouldn't matter. We'll just collect enough samples and just win. And that would be like a kind of a cool touchpoint demo for people in the field. The one that I was doing originally is, let me find it. Yeah, this one right here. I mean, you can pretty much implement whichever of these once I have the basics, but we're going to start with this. Okay. H. Pretty much we only have to, what do we have to do here? I don't like that the walls are added in a reset. That's really weird, right? So we're gonna have to clean up the reset. And then we gotta add like the doors thing to this. And then I think I have to hard code the solution to this as a test, right? So that we can see what's going on. Yeah, so let's do that. Yeah. We're just gonna like hard code this sequence of actions that will solve this instance, and then that will let us test. Essentially, that'll be our test to solve this thing. You put these here, and we'll just do int fixed. Where is it? Int actions. I think it's unsigned actions. Actions. And now I need to figure this out. So I think I have mine starting in the middle. Why do they start it here? It should start in the middle, right? Yeah. So we're gonna do north, north. So it's 1, 2, 3, 4, 5, 6. And then east, east 6, east, 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 east. That gets us, now we have to do south, west, 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 north, east, or west, Whoops. West. West. And then south a whole bunch. South. South. How many one? It's going to be 1, 2, 3. 12 south. That's 5, 6, 7, 8, 9, 10, 11, 12. Then we do east, east, 6 more. South. Okay, so that should be the solution to this. Which, like, that's hard to learn from scratch, right? How many do we have here? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 22, 23, 24, 25, 26, 27, 28, 41. Sequence of 41 actions to solve this environment. And you get no reward. I guess you'll get reward for getting the key. But it's not like just 41 actions, right? Like, I think you're definitely going to get the key randomly. We'll see whether, well, we'll see otherwise. Oh, I think I also have to change the way that the doors are, but that's fine. Int t. If t greater than equals 41, exit. And then we just do for yeah, we don't even need to do this. It's just gonna, it's one line. It's literally just env actions zeros actions of t. Okay. Grid. Expected. That compiles. Lib. Cool. So it doesn't move, which is weird, right? If is key down. Oh, t plus plus. Okay, so this spawns off screen, but nothing is happening here. Let's figure out why. Step here. Int f action vel y vel x. Okay, so I see. Well, they're velocities and they're weird, right? Hi, keep up the good work. Thank you. Currently what we're doing here is I am implementing this in Puffer ultra fast, and we're going to just try to solve this tabula rasa with very simple RL. I think we can do it. I'm a little... well, I said on Twitter I thought I could do it. I'm looking at it now, and I think it's going to depend. If you think of like a random agent having to get to this key, I think if you run it long enough, it'll get there. The question is if you... Are you going to be able to get to the key and then get back to the goal? Assuming I'm allowed to define like a reward for picking up a key, a reward for unlocking, and a reward for goal, I think that you can do it. I'll have to look up... What's this environment get? Okay, this is hard. They literally just give a success fail reward. Maybe we can do it. Maybe we can do it. Can you teach it something simpler? Yeah, you totally can. And that's curriculum learning. And that works tremendously well. But I don't think that that's going to impress like the RL community as much. Basically, this is just a short little exercise that shouldn't take me very long, right? Implementing something like this. This is like a couple of days of work maybe, total to like get a nice ultra fast C version of stuff like this engine. And the goal here is just like the RL people, they say right here, it's extremely difficult with vanilla RL alone. So like, what if I just did that, right? What if I just ran this thing for a billion steps because I can do it that fast and I just brute force it and like RL solves it? Having some simulations that start going to rooms. I don't understand your comment there. What do you mean? Also, I realize I have to have this window not be over camera. I always forget that. Discrete case only. Oh, I just have the wrong logic entirely here, don't I? I mean, having some help to prioritize going into rooms. Yeah, no, that will work. That will 100% work. I mean, in the extreme case, right, I could literally just draw a trail. I could just draw a reward trail to the key and then back, once you have the key, back to the goal, and it'll instantly solve the environment, right? This will be solved in like a few seconds. So maybe I should just make a couple quick comments here. This is actually a pretty good picture of what's wrong with RL in academia, because what you have here is what looks like a very simple environment that makes RL look really stupid when it fails to solve it, right? Like, this is so basic. Like, a toddler can do this, right? You go get the key and then you take it back. You can literally do that in, like, the first try immediately, right? So easy. Well, I mean, first of all, you have partial observability. That makes it a little harder, but you could still solve it in, like, a minute instead of 10 seconds, right? Like, you'd end up going into all the rooms first and then seeing, oh, okay, this is the one with the key, and I have to go back. And I also know that the door is red and the key is red, which the agent can't see and doesn't understand. But the bigger issue here is that without any guide rails whatsoever, every separation between the agent and reward is an exponentially deep search problem, right? So if you're going to say that the only reward is for solving the whole task, this is an exponentially deep search problem. So you've kind of just framed the problem in a way that makes something something that's really hard look really simple and makes RL look dumb, when RL is actually incredibly powerful, and this is kind of a contrived example. Can you break this up into smaller tasks, like one for going to different rooms, one? Yes, you absolutely can do that. You can absolutely do that, and the task will be very, very easy if you do that. And like, I would like to do that as well, because this task is not reasonable as posed, right? This is exponentially deep search to key, exponentially deep search back. And in fact, many much, much, much harder problems than this are easier for RL to learn because they at least have some sort of reward signal. So the point was, I was hoping that we can just brute force it and get it to work anyways, which I still think might work. We'll have to maybe cheat a little on the rewards if not, but I like that's not gonna get us any favors, right? If we do that, I think like the thing I kind of want to demonstrate here, like if I run this for 1 billion steps, eventually it's gonna find the key, right? Because it's not just a straight up like 41 coin flips in a row. That's not happening, right? It's like Brownian motion or whatever. So it'll eventually get the key. I don't know if it'll eventually get from the key all the way back. That might be harder. But maybe. If you run it for long enough. Right? Especially if I don't reset the agent. Right? If I just let this one agent wander around for a long enough time, like eventually it'll get the key and then it'll happen to get back, right? It'll just meander around the whole map long enough. And then it'll kind of learn something. Probably the first time it learns that, it'll just learn that, like, okay, getting to the green thing, like, if I'm next to the green thing, like, in here, I should be able to get back to it. That it'll probably learn very quickly, and then it'll take longer to get the whole thing. We'll see. But I think it should be doable. We'll see if I'm right. Does the agent see door colors? Yes, but not in the way that you or I would recognize. A good way to think about it would be if you randomized all the colors so that like they're all different colors, right? So that the different colored keys, like you have to figure out which key the door course, the D. It doesn't look like the key is the same color as the door. That's a good way of thinking about it. So this is another way in which the environment is misleading. Big problem with RL is doing stuff like this. But it's okay, we will win anyways. I also had somebody on Twitter tell me that tic-tac-toe is hard for RL to learn. So my hope is that we can just get this done quickly enough that I will also have time to just implement tic-tac-toe and immediately solve it, because it's not hard for RL at all. That's ridiculous. So simple. Yeah, it's not hard at all for RL. I don't know where the guy got that idea. But people have some really messed up notions about RL and what it can solve. Like RL's incredibly, incredibly powerful. People just been doing it wrong with very bad infra. RL's crazy good. I don't think people realize how good the RL is. There we go. But this is not what it's supposed to be. I don't know why this happened. The if. Was it float vel y? There we go. North. South. East. It got east wrong here. East should be 1 and west should be -1. And this should be... I don't know why it put the numbers in either. It should be like this. And it like repeated as well. There, let's try this. Okay, this is a little annoying that I can't, it'll load on the other screen. Let me watch it for a second. Why? I gotta, like, slow this down. See. We'll just run it with GDB. I play bridge with friends on the weekends. Can we teach machines to play it? So yes, we can. Our AI has been used for like for poker and such before. Infrastructure wise, there are a couple like the answer to a lot of these things with RL, it's almost always yes. It's just that the infrastructure is a little bit tricky. So with card games in particular, the only real difficulty is that it's a turn-based game, and the infrastructure required for turn-based games is a little bit different. I technically already support it in Pufferlib, it's just not as efficient as it could be. Let me think. Multi-agent definitely works, right, with RL. Card games definitely work. I've been wanting to do this for a while now, honestly. Like to get like a better turn-based system working for like card and board games. I should definitely do that. Yeah. I think OpenSpiel's in C, isn't it? C++. I could technically bind this to Puffer with C++. I think that they went crazy with this and have like all sorts of stuff in like a million different languages. Or maybe it's just the bindings in different languages. They have bridge in here? Oh look, they got bridge right here. How hard is this? Jeez. How do you have 1,000 lines for this? This is like... This is obnoxiously overbuilt C++ code. I mean, I could just bind it. I don't know how fast this thing is. 88 lines. 6 lines. What's this? Okay, variant. Okay, not as bad as I thought. It's 870 lines. I'm probably, like, half of this is probably fluff. They've also got all this additional jank, though. Like, this is not a standalone at all. I can probably still get a binding for this at some point. It's just a question of whether people would actually use it. It's also, these games become dramatically easier if you just use, like, hard-coded AI opponents. So, like, you know how if you, like, you play bridge, you play poker online versus an AI, like a classic AI, not a neural network? That makes it easier just from the perspective of the infrastructure. So we could do that, maybe. Yeah, this is a funky project. They're still merging stuff on this. I already technically have a binding for it as well. I should do something at some point with this. 2 stages. One where you form contract with partial information. You play out the contract. Partial information communicate. Okay, I will have to look that up then. Yeah, partial information. RL does partial information. RL does communication. I mean, you might not be familiar with this then, but like, let me just give you an idea. This is going to be like not a card game, but this is my favorite result in all of RL. Let me see if I can find like GIFs of this thing. This is going to give me dumb ads. Okay, so like, where's the... So this is Dota. This is a ludicrously complicated 5 versus 5 team game. It has well over 100 characters. They all play differently. You get 5 on your team. The opponent team has a different 5 on their team. You get crazy numbers of interactions between all of these characters. There's like there are these waves of minions that have their own mechanics that everything interacts with differently. There are these towers you have to defend. It's this like mind-bogglingly complicated game that takes weeks at least to even get a grasp of what on earth is going on. RL solves this trained from scratch on its own with a relatively simple and small neural network. That is what RL can do. RL is nuts in what it is capable of. The infrastructure is very hard, though. That's the key thing. Infrastructure is very, very hard to get right. That's what I've been trying to build with Puffer. And, like, we have my version, which is way simpler, admittedly, right? But I've been trying to build towards this. It's like a similar style of game here with, like, different characters that play differently. A lot of, like, the same mechanics. Obviously, I don't have all the nice graphics, right? But, yeah, RL's crazy good. So the answer is almost always yes. If you have, like, a game that you can simulate fast from scratch. Is this the game you were working on previously? Yeah. Yeah, Dota's like the game. It's very similar. The game I was working on is inspired by it. What was the main issue with masking for turn-based games? There's no issue, Nathan. It's just inefficient because you need the observation buffer to be a fixed size, right? So you have like player 1, player 2, player 3, and if you do like a round robin type thing, then you have to get like observation for player 1, padding, so you're sending padding through inefficiently, wasting compute, and then like, you know, padding observation for player 2, you know, padding, send that through. So there's just an inefficiency, that's all it is. I have multiple environments that work in Puffer right now that work like this. It's just not as fast as it should be because of that. And it's a pretty tricky thing to work around. I'm still thinking about that, but it's a little tricky. What if you do single agent playing everyone? Store number of players. It still doesn't work, Nathan, because the actions aren't simultaneous. It's turn-based, right? So you have to wait for the first player. Store player of each move. The issue is that it's turn-based, is the thing, right? It's like you have to wait in order to apply the actions, even if it's the same policy, right? You can't select the action simultaneously. I love watching people play games on a high level, and so this looks like magic. Yeah, it really is magic. Like, if you haven't played Dota, it is a mind-bogglingly complicated game. Like, I think if you talk to most people, especially people who don't play video games in particular, like, you legitimately would not believe that people have something this complicated as a hobby. It is a ridiculously complicated game. Um, I remember the first time I tried to play the game, right? And I've played games. I grew up playing games, right? I've played tons of games, some very complex games. I was still like shocked at the depth that was there. It like, I mean, you can play the game for a year and still have no idea what you're doing. It's nuts. How does the ML learn what's the best thing to do? So many moves. How does it select the best one? It starts off completely random. It starts off playing the game completely randomly, and based on trial and error, it figures out what works and what doesn't, and then it gets smarter at it learns kind of like a human would, right? It starts off doing stuff that's basically random. It actually starts off worse than a human because it is actually random, not just like kind of random and somewhat coherent. And over time, based on a reward signal, based on it winning or losing the game, based on it leveling up, getting experience, all the things in the game, it learns what works and what doesn't, and it becomes more coherent at learning to make progress. Say there's a single agent playing both players. Then each step we collect one action and one reward. Each step we collect one action and one reward. The end. Each step we collect one. So Nathan, that is what we do, but you still need the buffers to have the padding. Unless technically, yes, you could do it the way that you're suggesting, but there would still be additional code because you need to know which observations correspond to which agents when you're computing trajectory segments, which is what the position in the observation tells you. You'd need like an additional IDs thing, which technically the envpool API does this for you, so you can do it, but it doesn't necessarily make things immediately easier. Maybe it does. Let me think. Is that the solution? That's probably the solution, huh? Do you have to pass IDs? Yeah, I think you're right. I think you can do it. It's just kind of a pain. Yeah. Yeah, I could do it that way. It'd be a little tricky. You're storing one ID per step instead of N. Yeah, you're right, Nathan. You could do it. I'd have to make some changes to the VEC infra, but I could do it. If people want turn-based games, actually for your thing, if your game is, we'll get your game working with the masking, and then if you produce something cool, I'll do it for you. How about that? That's a big ask because it's a kind of tricky piece of code to change, but I'll do it. I mean, it would be a really nice improvement to Pufferlib anyways. I hope I'm not missing something, but I'm pretty sure the thing that you're describing, with a couple little tweaks would work. Speaking of which, how's your stuff going? We got your Pong online. For folks watching, Nathan wrote this. I just ported it. It's his code. Ah. It's very hard. Boom. I tried playing it and never won. I don't know if the ball moves too quickly or if the opponent is too good. I think that we should make some changes. The actual Atari version of Pong is very hard, but I think that we actually messed up with the Atari bindings because I was talking with my mother and she said that she had Pong like the console, the original Atari console growing up, and the ball moved really slow. So I don't know what the heck we did when we messed with Atari in RL, but like all the versions that I've ever seen used for RL have the ball moving obnoxiously quickly, and like the paddle can almost not get there in time. I've gotten 1 point on this thing before. Here, I'll do it real quick. If I can manage it, I'll get a point real quick. Can I do it? Freaking hard. I think your goal is to like hard bounce it off of a wall or something. I have to figure out how the velocity works on it. There it goes. I just got a point. There you go. See? I got 1 point there by hard bouncing it off of a wall. It's hard, though. It's very hard. Y speeds up if you hit the ball while moving in the same direction as the ball is going. X never changes. I say. But it's hard because like the paddle control is not precise enough to like consistently get it. Maybe it's just the frame skip, to be fair. But here, I got a point, so it's possible. My agent learned it. You just gotta improve. Does it? Do you have an agent that plays it already? Did I miss a Discord post? Do you actually get perfect score in that thing? I'd be impressed. I didn't miss any posts. Also, the puffer boxes will be back soon. I had to call main gear for that today. I'd like to try learning how to do stuff like this. You totally can. The code is not that bad for a lot of it. It's pretty low level, but it's not in order to make it fast, but it's not that bad. Here, where's the Pong code? I'll link it to you. It's all open source. Star the puffer. So it's in this dev branch. It's like this obnoxious environments, ocean. Yeah, here's Pong, Pong.h. One of my economics classes had an example where we found which arm was best to pull. Yeah, that's a classic. Multi-arm bandits is a classic mathematical phrasing of reinforcement learning. We technically have an environment in Pufferlib as a test that is exactly that. Here. Sanity. Oops. At the top. Yeah, right here. This is literally that. Right here. Here. This is literally multi-arm bandit. Tiny little bit of code. It's not the full problem. There are lots of versions of that problem, so you can define it in many ways. But this is the gist of it. We use it as one of our sanity tests. RL will, like, trivially solve that. It won't get you the, it won't solve it, like, in the optimal number of checks or anything, because for specific versions of that, they're, like, you know, proven optimal algorithms or whatever, but it will solve it, and it'll solve much harder versions where the optimal algorithms don't exist. Reward. Let me see. Doing something here, right? Yeah. If deskTile is reward. Should be is open deskTile like this. Check disk. Ho ho. Oh, I did miss a message. That's really weird, Nathan. Usually you don't change frame skip at eval time because it can mess up the algorithm. Because like it assumes it's gonna have to move all four. Huh. You're not required to use frame skip 4 during training. This is the same version of the game? Dude, this is good. I should try playing this with frame skip 1 at eval though, because I think it would be a little easier. I still would not be able to play it this well. Have you fiddled with the 2 minutes is awesome. Have you fiddled with the settings at all to try to get it to like hit 1,000,000 train steps per second? What's frame skip? Frame skip is the number of frames for which your agent will just repeat the same action. It's an efficiency metric. It's an efficiency optimization, so that instead of having to send the data to the neural network on every single frame, you only do it every 4 frames. But then it has to repeat the same action for 4 frames. So like if you're gonna hold down, like if you're gonna press right, then it has to go right for 4 frames, which is like nice, but also sometimes you need more precise control than that. Welcome. Oh, now we've got Noah here as well. Hey, Noah, you saw this. I think I showed you this the other day, right? Or maybe you haven't seen this yet. We've got yours and Nathan's environments online on Puffer GG. There will be attribution at the top of this page as soon as I figure out how to do it. The HTML is auto-generated for this because of mscripting. So, you'll have your name at the top of this as soon as I figure out how to do that. And if I can't figure out how to do it, I'll just, like, put it on top of the game or something. Or in the link to it. But yeah, here it is. If I get higher SPS on smaller horizons, and it doesn't get as much signal, not sure how to solve that. You increase the batch size, typically, Nathan. You use stupidly big batch sizes. I mean, it's fine to have it be, like, it's fine not to do that. I think that you could solve this in less than 30 seconds, though. Would be my guess. Probably faster. Did I tell you, there's this NYU lab that has this GPU driving sim, and I took their train time from 2 hours down to 28 seconds with Puffer. That was pretty fun. Not on all the versions of it just yet, but it will be on all the versions as soon as they get a couple little efficiency optimizations. 2 minutes is 30 seconds, 4090. Well, then we can do it in 10, right? I mean, it doesn't really matter at that point. It's kind of just like a flex, but it's still kind of funny. PR the hyperparams for this if you want, so that like PR the hyperparameters and stuff for this if you want. And it's cool that if this actually works with frameskip 1 at eval, then we'll be able to upload like the bot, and you can play against it as the opponent. Yeah, maybe we'll make it so that like the green agent is the RL one or something at eval or something. I don't know. I can help with that. Unbeatable. Like unbeatable Pong RL agent. Sounds good. after I submit my thesis. Need to figure out how to do RL versus RL at eval. We can do that as well. After I submit my thesis at the end of the month, I can integrate the other changes on Breakout into the C code. Awesome. That'd be great. Yeah, the challenge I gave to you and Nathan would be to, I mean, it looks like Nathan did it, but, like, just train, like, a really good agent on your environment, right? We do have the ability to load the agents onto the web now, so. This is very cool. Gotta go. Thank you. Thanks for dropping by. Okay, I think I messed something up here. So north, 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 east, east, south, west, 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 north. I think there's supposed to be another north in here. Breakouts training at 800 on 800K. Yeah, okay, that's good then. Already ran carb sweep. Getting good agents should be fairly easy. That's what we want to hear. What's happening with this thing? Let's just do GDB. Break. A8. 1. Okay. So. And it doesn't have the ability to pick up the key as Y. It's also occurred to me that we don't have the ability, like the open doors thing doesn't even really make sense. Well, it's fine. We'll mess with this in a bit. Let's get the keys. Are you working on a pupperlip grid world? Kinda. I just figured we'd do a mini grid env. You know, as a quick thing. So it gets the key. Okay, so I was wrong. There's 2. This additional north is not needed. Okay. We get overflow. Keys is 6. Huh? Dev till you die. How about dev and solve AI and not die? That sounds good. AI for mortality. Welcome, Will. What's going on? Has O1 got you? Has O1 got you down or something? Your repo looks like it's doing pretty well. Oh, I just messed this up is all. That's funny that this didn't catch that. No, just trying to solve really stupid DX stuff. DX. Have you tried integrating? Heh. The emoji still comes up as a water pistol on this. Oh, developer experience, okay. The best thing I've done for developer experience so far has been putting the source code to things, for things into brain dead signal files. It's honestly the best thing I've done for developer experience. More than APIs or shenanigans or whatever. It's like, yeah, here's all the code. It's just right here. It's really simple. You know? Why do complicated thing when simple things suffice? Like, even if I do, like, no abstractions. Stop trying to think of clever abstractions. Just don't use any, right? This MOBA's 2,000 some odd lines of C. And I guarantee you that any scheme that you can think of to, like, break this up into multiple files or, like, abstract out various components is going to make it harder, not easier, for people to understand what the heck this is all about. Bare minimum abstraction. Okay, maybe this data could go back into the data.h file or whatever. That's about it, though. Each of these envs is like a pretty much standalone .h. And then I work on stuff like how do we have less boilerplate a lot, right? Like I've been trying to figure out how to reduce the amount of boilerplate Python you need in order to bind these CMs to Python, stuff like that. That's pretty much what I've been doing. It's been going very nicely. It's really cool to be able to onboard more people, like new people, new contributors, and just say, yeah, here, read this file. It's like completely brain dead code, right? You just read the file top to bottom. Like you can ask me questions, but I promise you're not going to have any. Could do that for sure in L. I mean, what's the code footprint of it, right? Is it like... It gets sketchy beyond a certain size. But it, like, that size is larger than people think. Like, pufferlib vectorization is one file. The whole vectorization is one file. Pufferlib emulation is one file. We have a bunch of wrappers and obnoxious other things that take up more files, but generally I'd like to reduce the amount of files and the amount of, like, abstractions, not increase it. Eventually there's just going to be a pufferlib.c or pufferlib.h one of these days. We can do that after we get revenue. Speaking of which, I think it's about time to start sending out some emails with that company of yours. So I might want to be paying you. Because I've been getting a couple organic leads on stuff, but it could use some help. And I hate networking. Pufferlib on pip? Well, Puffer's not on a performance improvement plan, but yes, the package is on the repository. It's 1.0, mind you. So, like, the core tools in 1.0 are there. The demo and train scripts are meant to be user-edited, so those are from source. And then the dev stuff is obviously on dev. Pip install Pufferlib, though, for 1.0. Back to work. Good luck with your stuff. We're making mini grid. Gets the key. And then it fails. Agent keys. Desk tile. Minus key 1. Oh. I think I know. Wish I could get these to spawn on my same monitor. Doesn't open the door still. The destination's a locked door. Do I have the wrong color key? Isn't the key red? No, I have the right color key. Totally. Oh, we literally just messed this up is all. I just messed this up, that's all. That's dumb. Agent keys is equal to 1. Like this, right? We didn't get a reached goal. Where's the reached goal? What happened? Looks like it got stuck at the end, right? No. Yeah, not printing anything. Was it not detecting the goal? Are we just not running it long enough? Yep, we're not running it long enough. That was it. Here, we'll do this, and now it should work. Oop. Yay! Reach goal. So we gotta clean this up a bunch, but that's the basics of it, right? That is the basics. Those are the basics. I think I kind of want to just bind this and start training on it instead of making it 1-to-1 exactly. I use gray for the walls. This is the only time they get a reward, so this should be good. Huh. Let's just get the binding done for this thing. This is the boilerplate that annoys me, but we'll try to get through this quickly. Just do observations, rewards, and dones. And then the constants, right? Yeah, self.env equals init grid. This is going to be find grid.data star. Oh, this needs to be allocate, doesn't it? Yeah. We need to change a couple things. Which is a bit obnoxious because, like, we're gonna end up having to change them back. But it's okay. These have to go here. It's cool, right? Observations, actions, rewards. Yeah, okay. So these are going to be allocated here. And then we just do free env. Then we just do wait free env. Free all these buffers. Should be good. Free test. Undeclared identifier grid. Huh? Oh, right here. That's good. Because this doesn't need to be here. This needs to just go away. And then this is init grid. Unsigned char star. This is observations, data, actions, rewards. This now needs to be... Is there no done signal? That's a problem. I wish there were a better way to do this. Load star dones. Star dones. Grid agents. Okay. With height vision. Cool. So what I'm trying to do here is I'm just trying to pass all this data from Python so that when I update it in C, it just gets updated in Python rather than having to copy it. Eventually, what you can do is you can have all the memory allocations come from Python, and then you have full transparent access to the game state from Python. That's really nice. That takes a little bit more work. I haven't figured out how to minimize the boilerplate associated with it as the main obnoxious thing. Well, we can delete this block. I don't need it anymore. We really don't need any of this garbage, do we? Okay, I'm sure that there's stuff missing here, but... Yeah, we need, like, step, don't we? Step and reset at least. 3. Okay, so this still runs. Demo is still a-okay. And now we have to get the binding for this thing. X. What do we think? Right here? In place. Let me check one thing real quick. Expected 9 got 10. Observations, actions, rewards, dones. Forgot to add it here. Where's sea snake being used? This should be env. Oops. Self.env. Observations with height. Horizon. Still doesn't build. I think this takes a seed, doesn't it? Seed. Or 2. Whatever. Okay, so this now builds. Oops. This now builds. We want to go grab the signature from SciGrid. Width, height, oops, we'll put this here. So we have width, height, the moderately obnoxious thing is we didn't actually bind the make function for this specific environment, right? I guess that's not terrible. We can just do render mode for now, like this. We do need ob size, right? Vision equals 3. What's happened here? I deleted a class, okay. Get this. Get rid of all this. Don't need any of this to be in Python land anymore. It's gonna be 1, zeros. Episode rewards. We need this? I don't think so. I think all we need is, this will get set in a reset. There's like a bunch of just garbage in here. I forgot there's just so much boilerplate. It's gonna take a quick, it's gonna take a second. Space. Yeah, we have the whole freaking client in here, don't we? Just do this. Yeah, like literally none of these things need to be here anymore. Secret. We don't need any of these things. It should literally just be, actually I copied the wrong signature, didn't I? No. Wait, what am I doing? Self.buff.observations. .actions. Rewards dones. The heck, what am I doing? Something like this. Agents I 0. Episode reward 0. So much garbage here. Right. No longer need any of this. Just need this. Buff rewards fill 0. Way too much code here. I'm realizing that I have quite a bit to port if I want to replicate both this new thing and the functionality of my old grid env. This might end up being a few day project instead of like a 1 day project like I intended it to. But it's okay, because we'll get like, I mean, this is the last other environment that I'd already built that's like, at least other than the secret one. So getting this online will be cool. You know, we'll have a lot of different versions of this that we can put online. I'm getting like brain lag doing this, I don't know. Come on. Okay, now we should be able to debug this, right? Buffer grid has no buffer grid agents. None. Let's maybe we just bind like this for now. And then we like, oops. Like maybe what we do is we just put this. We put this into grid.h, right? And like presets or whatever. And then we go right here. We don't actually need this if you think about it, right? We just need like this. And then we'll do, like, we don't even need this. Just like this. Oh, we don't even have vision in the SIG. Just do this. One given, reset. Invalid action. Okay. What's happening here is I have crazy settings and that they're not optimized well enough yet. Yeah, you can see the batch size is like something crazy. And then the number of M's here should probably be, let's just do like this, I don't know. Oh, wait, env batch size should be 4 probably, right? Or 512. Yeah, there you go. So now that's like an initial train thing working. This is more than an order of magnitude too slow, so we'll fix that. And we'll fix a bunch of other things from here. And basically the goal then today will be to solve this environment, to get it working and to solve it. I have no idea how hard it'll be to solve it. We could do some back of the envelope, but maybe, you know. I'm gonna be right back. I'm just gonna use the restroom real quick, grab a drink, and then we'll get logging into this. I'll show you how we're gonna speed this up and so on. Be right back. Oof, sore. You know, I'm realizing here that once we do this, if I just bind some existing board games for some stuff, we're gonna have a whole bunch of more environments that are like already implemented fast. Assuming actually that there are fast implementations of board games, but like, you know, throw in Puffer Limit Chess. That could be kind of cool, right? I don't know. Maybe the Alpha Zero stuff is just like dated. Maybe we can just do stuff better. I'm sure MCTS is hard to beat without MCTS, but maybe it's just fast enough. Maybe we have the technology. Twitter was blowing up. The heck is going on here? Oh, literally just a meme. Okay, nothing doing here. Let's go back to real work. Hey P-dubs, how's it going? We're implementing this thing for Puffer today, super fast. Because it says that you can't really solve it with vanilla RL. But I think we probably can. Also, Pokemon has been somewhat stalled by the hardware kerfuffle, but I just got off main gear with main gear today, and they say they're gonna do some part swaps and send the stuff back. I think I showed, I don't know if I showed you this, but this is cool. We have M's online now. They're like playable. They're not fully finished yet, but like, you know, beta of Puffer MOBA. Dash strike the neutrals. There's like, where's it? Who's cool? Oh yeah, this guy's cool. Yeah, we've got the Snake Env, and then we have some by contributors that I just ported over. They did it in Scython, and then I helped with the C port. So we got Breakout and Pong now, and they're ludicrously fast. We haven't even full optimized them yet, and they are ludicrously fast. Like, why are we wasting all this compute on slow M's when we can just make the M's be fast and solve the same exact problem but faster? Yeah. So we're gonna add mini grid to this. We're gonna try to get a build of mini grid to add to this today, or like Puffer mini grid at least with a couple scenarios. Maybe it'll take me a couple days. We'll see. We'll go from there. I've been enjoying my C. I've been very much enjoying my C. I will agree with you that if I did this in C++, it would probably not be a lot of fun. But I'm liking my very brain dead simple C. Let me figure out what I want to fix here. I think we just need to get like a step all function, right? Is there any reason that we need a step all in C instead of Scython? Not really. Like this. Halleck. Is it size of env? I guess it is. But this is also, this allocates as well. Is this supposed to be an M star star? I don't like M star star though. Okay, that is somewhat obnoxious. Because this is technically an M star star. We'll do this gross thing for now. This should be fine, right? Clean standard lip. We also don't have, we need the header stuff, don't we? Oops. Yeah, we need all this. We want Kalek, not Malik. Reset. Okay. Cannot assign. Okay, we'll just do M star star. Whoops. This angle bracket cast syntax. Then I'm sure this is, we're missing an arg. Yep, we're missing an arg. Oh, we got a fair few folks on YouTube at the moment. Welcome, everyone. We're currently implementing this little RL environment. It's very simple, but this is like, well, it looks simple, but it's a pain to solve. But regardless, this is like a very common thing that's played around with an RL. We're implementing it really, really fast in pufferlib. And yeah, we're going to go from there. So hopefully we'll have some version. If I can get this written fast, we'll have some version of this online end of today is the hope. We'll see, though. I got a really late start today. I got to bed on time and everything. I was like all ready to get an early start today, and I just couldn't sleep. Too much cool stuff going on. So I messed up my schedule a bit. agents. Well, let's try this. No attribute num envs. It's like funny because I'm at a stage now where everything here makes sense. Like everything I'm doing here makes complete sense to me, but there's just too much boilerplate. It's like too clunky, you know what I mean? Like I know every single thing that's going wrong here. Everything is very easy, but there's just too much boilerplate. Also, this is about to make a trillion environments, so let's fix that before that happens. Num_envs is going to be 2. Batch size will be 2. I think this is how it works, right? Oops. Env takes 0 time. Interesting. I don't know what's going on with the training taking that long. That's weird. Oh, probably we just have some janky hyperparameters or something. Yeah, here it is. Yeah, we got batch size. Mini batch size can be like 32K. Batch size will be like 128. 120. What's 32K times 4? It's like 129 or something. 131. I should know that. Interesting. I do something weird? Yes, I did. This is insane. This is supposed to be 16, and this is supposed to be 131. There we go. There's 400K. And we're on the not as good desktop at the moment. So that's nice and fast, but we're not actually passing the data around that we should be. So we need to fix that. Which really shouldn't be very hard. We're really just suffering under the weight of these bindings, to be honest with you. That's just the main thing that's a pain, the weight of the bindings. Alright, let's see how this is done. So yeah, this make locked room and this needs to be we need like env star init locked room env or whatever, right? And most of this code should go there. So we're going to copy the impl. And this is going to be oops, down here. Okay, so now we have an init function instead of an allocate function to add the unsigned activations, actions, rewards, float stunts. Okay, cool. So now we have an init version of this that takes all of this. And now the allocate function, or the make function, should be very, very simple by comparison, because this should just be let me see. My head hurts. Get rid of this for now. Let's just get this working for testing. Errored. Sign grid. Init locked room. Okay, sure. We'll just call this the make. This will just have to be obnoxiously quick and dirty until we figure this out, because it's just like the thing that's like the reason I'm being completely incoherent at the moment with this is that like when you want to run this code from C, you have to allocate all the data. But then when you want to run this from Python, you have to pass in all the data structures so that data gets mirrored to between Python and C. And then you also have to run many of these environments in the same time in the same process, and you have to make sure that the specific slices of data go there. And none of this is particularly difficult, but it's very annoying to do without like scattering these giant function call signatures everywhere, and having lots of different versions of them, and it's very confused. But I mean, regardless, we should be able to get like a basic thing training first, and then we can figure out how to like make this easier in a bit. I really would like to just have this thing training today by whatever means necessary. So this needs to have unsigned. This needs to have a different signature. And then this needs to also get the this is where it gets to be a little obnoxious, right? I think it's see, so this is kind of wrong. It's observations like of I dot data. I think this should do it. Python objects. Can we not do this? Is it just binding too tightly? I don't think it should in C. But here, let's just make sure. Python objects cannot be cast to pointers of primitive types. You sure? Oh, because it doesn't know that this is a NumPy array as well. That's obnoxious. CNP the array. Yeah, I think you have to do this. It's just not the compiler doesn't know. It gets confused between Python and C types even when it's correct, I think. Syntax error. And simple. Really, what's wrong with this? Observations. This is why I think that actually the C is easier than the Cython. The C has actual error messages that make sense. What the hell is this, right? And simple and the array. Syntax error. Oh, I'm dumb. It's literally just this. But like the fact that it doesn't give you a reasonable error message is really obnoxious. And yeah, you're not allowed to have you're not allowed to have declarations in loops. So I have to do this, right? And then I have to do like this. And now it'll build. Almost. Re-8 2. What's wrong here? Oh, do I have the wrong types? What's wrong with this? Oh. I copied. I don't know how I did that. Reasonable error messages. Reasonable error messages. My kingdom for reasonable error messages. And do we need all this? This is agent speed, right? Okay, finally, compiles. Cannot convert. Okay. Cannot convert. Grid. Oh, hold on. Hold on. You need to pass a slice here. It needs to be a slice. Like this. Because otherwise, because you're slicing a single thing, a single variable, it just turns it into an int. You want the memory view? Malloc invalid size. Okay. Invalid size? What's wrong with this? Invalid size unsorted. What happens by... Okay, so this has got to be the invalid size. If you do 8, this is disgusting, never do this, but... Still invalid, really? I thought I'd just do the size of a pointer. I could do this portion in, I could do this portion in C, I guess. Instead of doing it in the Python layer. Might be a little easier. This has gotta be because the type is not fully defined, right? I would imagine. Can I just like paste this stuff? But then I have to do the agent as well. Freaking Python. You really need better ways to bind stuff from C. Those bindings are just disgusting. C-type def struct. You just have to... We'll leave the semicolons on. It doesn't hurt anything. But this is what I mean by the bindings being a total pain. Like, I'm doing this in the hopes that this will make the compiler understand what I'm trying to do with this allocation. Now I gotta do... Now I have to do bool to bint because for some reason bool doesn't work in Python. Then I have num keys here, which is like 6, hard code, whatever. Still doesn't malloc. Size of n star, maybe? This should give me 8. Is it not an m star? It should be an m star, no? I mean, m star star. I mean, I can do this. I don't think this is correct, though. Yeah, you see? Nah, this should be correct like this. Something's weird. Let me just make sure that it's actually crashing where I think. Maybe it's not crashing where I think. See, it's not crashing where I thought. Malloc invalid size. Alright, where is it, where is it allocating wrong size? Invalid size unsorted. It's on the second call. That's weird. Maybe self.envs of I. No, this looks good. What is the invalid size being passed? I wonder. Width times height. Num agents. These are all hard-coded, it should be fine. Could be this stuff down here that I'm overwriting, maybe. I have address sanitizer on, though. What even is this? Yeah, so overwriting some memory. I should just redo the binding for C. I should just, like, do this from C. And that should probably find the error. In fact, I mean, I could just, like, do the make all thing and C. That would also probably find it. I probably should not be doing my allocations from Python. That's like the one place I probably should not be doing them, right? Mm. Lock room M. How can I rewrite this? Maybe it should be like a setup or something. It's like weird because the init function needs width and height and such, right? So this has to call the initializer. I don't know why I'm stuck on this. This should be very, very easy. Like tremendously, tremendously easy. But something is just not clicking here. Like the issue... I guess the issue is just like not having default parameters, I guess, is making it clunky. It really shouldn't matter that much. Yeah, because like this is... These are fixed anyways, right? I mean, I could just, for now, right? If I don't mind doing it this way, and like just completely ignoring, for now, we can just do allocate here. And then I can go to grid.c. And now this can be alloc. This is allocate. Jeez. Okay. What? Oh. This is totally fine. This 408 bytes is from Raylib. What, can I like not allocate multiple of these or something? Is that what's going on? That's star. Do this. This goes to the top. And then we'll just do like I less than 41. Plus. Just do that. I'm just trying to see if we can reproduce this weird memory bug so we can get this thing running already. Okay, so we're leaking a bunch of bytes. Let's figure out what we're leaking. Oh, well, so we're obviously leaking. We didn't free this, right? So we have to close. Free allocated grid. And then we're going to do, whoops, preamps. Okay, so we do have a double free here. Free env. Okay, so this free allocated function is redundant. Allocate does obs actions rewards dones. Agents. So this allocates env grid agents. There we go. No more memory leaks. Does this help the No? Doesn't like it still? Well, maybe we should just do all of our inits from C, because this is obnoxious, right? We saw how easy it was to do this in pure C. I mean, it's pretty much just this code right here. The only thing is we're going to have to map observations over, but it's not that great. Now, we're going to just do it in here because I know that this should work. Allocate locked room env. We're going to, this is init locked room env or whatever, right? Make locked room env. Make locked rooms. Unsigned. Like this. This is almost right, but we have to do the offset here. This is and observations of I times, well, the vision is 3, so 7 times 7 or something. Obviously, we're not going to leave this hard-coded. Fine. Thumbs. Okay. Reset. I. And that is all. And then you can just do step envs. Wait, step envs. Right. Three envs. Reset envs. Bind all this to Python. Don't need this, don't need this. So now this goes, we still have m star star here, but now we get to directly pass in, this gets to just be make locked rooms with all these data types like this. And then we'll just do reset ends like this. Into here. So we don't even have the loop in Python, which is no big deal either way, but step ends. Sure, this is fine. And then we have free ends. Okay, so this test still passes, it still compiles. Cannot assign preems. Cannot assign type m star star. Huh? Oh, it's all in all of them, right? That. Okay, so we have the same bug. Reset ems. Cannot assign. We don't have it on the make though, we just have it on this. It takes m star star m's, right? Cannot assign type m star star to m star. This is why you never use frickin' double pointers. Like, ever. If I had been smarter, I would have written it in a way that wouldn't have required it, which I know how to do. but it would require some more work at this point. Is this actually happening? What? Reset M's. Oh, it messed up the signatures here. Damn it. I don't know why I didn't get the error on make locked M's. I should have gotten the error up top. There we go. Cool. So now this is training, and maybe there's actually reasonable data coming through this. Maybe. I mean, regardless, let's figure out what we're going to do here. We definitely need to get rewards from this. I'm trying to think how I want to record this data. I like mentally got some sort of block with this right now. I don't know what it is. I think it's just making me uncomfortable that like all this binding stuff is just making me very uncomfortable. Because like I know that there's so many places that could have potential errors. But I really just need to charge ahead with this and get something running. This is absolutely awful code though. We got Horizon. And is there time step on here? Tick. Do like this. Grid. Reset. Just do. Tick is 0. If tick equal Horizon. Do I want this to reset it or do I want to reset it? I want this to reset it, right? I don't want to even bother setting duns. The thing that's bothering me, I think I figured out what it is. The thing that is bothering me here is that I know that this is like a very sparse task that's going to require this thing to be really correct, and it's going to be very difficult for me to tell whether it's really correct if I mess little things up here and there. So, but there are ways around that. I can leave like a reward trail or something. It's still just bothering me, and it's bothering me to the point that I'm like stuck on writing code because I know that there are going to be issues. Mf tick is gonna. I'm like really tempted to just take a step back and try to do this thing correctly, as this is driving me nuts. It's also 4 and I haven't had a. I need to get like a shake and some stuff. Like what I should have done here. Are you using PPO to train all these M's? Yeah. PPO kind of just solves everything when things are fast enough, as far as we've seen. When you have good hyperparameter sweeps and good infra. Let me see if I'm making some oversight here, because I mean, it really shouldn't be that bad. Yeah. I think I'm just overthinking it. All I need to do is I need to figure out a good way to get trajectory rewards, and I should be set. How do I get that data back to the environment cleanly when this has to run this fast? Because I don't want to loop over all these M's in Python, right? I don't know what the mental block is here. It should be so easy. There's something I'm like missing. I guess it's because like if you actually have to write any loop in Python, since it's single agent, like it's way worse than in the multi-agent case, I guess. So return. Drink a shake. Other PIs making gains right now. While this PI here squatted after nearly killing myself. Luckily I had safeties. Where's the thing? I should go get my shake though, you're right. My head is just all fuzzy. This is 265. 265 for 3 sets of 5. I think I'm pretty good there. Hey, Akarsh, how's it going, man? I'm currently trying to implement mini-grid at like 10 million steps a second, and I'm being very dumb about it. How's it going, though? Akarsh is one of Philip's students, former lab mate. I guess you're probably back at MIT, right? Is MIT must have started by now, right? Hope your summer's been good. Have you seen these? These are fun. It's not quite League, but you know, it's a little bit of it. You got some classics as well. A-Life project wrapping up. Cool. Very nice. I was trying to figure out how to implement mini-grid very fast, but then I just like, I don't know. There are a couple weird things with this that I didn't run into for some reason with the other M's. I mean, they should in theory be the exact same, come to think of it. Didn't I literally do this in Pong? The bindings here? I guess it's this reward sum thing. Yeah, I guess I just did it in Python. Oh no, there is some additional logging here. Efros came to MIT and chatted. Building a large A-Life simulator and training agents in it is doomed to succeed. That's cool. I am somewhat, well, I don't know if I'd say suspicious. I think you'll get cool behaviors out of A Life for sure. A Life style Sims. It's very hard to make them interpretable without tying them to something like a game, though. But yeah, as for building Sims, we're pretty much at a point where we can build whatever we want ultra fast now. And if we have Puffer, we'll actually keep up with it, which is nice. You know, we've got million step per second training runs once you optimize a bit. Neural MMO style Sims. Oh, I gotta get my secret project done then. It's been like basically releasable for a long time now. But what happened, you see, is I didn't want to release it without it being like something that would catch on and a lot of people would get to see and interact with. So I started porting it to C so I could put it on the web, and that's going to take a little time. I actually have a demo of it ready, but it needs a little bit more work. It's like 3,000 lines of C plus a couple of shaders. It's even longer than the MOBA, like 50% more code than the MOBA. It's quite a bit. I think the next patch to Pufferlib is going to be close to 10,000 lines of C for the next Pufferlib update, which is way larger than the size of the Pufferlib core. The key errors that I've seen with a lot of these simulators that people build, right, is they try to do them in jacks, and then they get limited on what they can actually build, or they don't do them in jacks, but they do them in Python or whatever, and they end up being slow. Those are the two main things I've seen. When's Come on, this is so simple. I should be able to have Well, there are kind of like things that are a bit wrong here, right? Because this win rate thing needs to get reset. Oh no, it is correct, isn't it? Uh, Not quite, maybe. Hmm. Okay, I really need to just go make a shake and take a few minutes because my brain is just like not letting me think about very simple things at this point. Um, I basically all that needs to happen here is I just need to come up with a clean and slightly more efficient way than this to get the log data back into the mini grid env, and we should already be able to train. And I really want to have that working today so we can actually see things being solved. So yeah, I'm gonna take a couple of minutes real quick. I'm gonna do that, and then I'll be right back, and we'll finish this properly. Okay. So I don't think I was being as dumb as I thought with the original thing. There is kind of a little bit of subtlety to it. There's a little bit more subtlety than I originally gave the problem credit for. I think I really want this layer in Python. Um, or rather, I really want this layer here in Python. Do I? Well, to be fair, I can have these functions be in Python. I mean, in C. This is fine, right? And like for now, at least. Oops. I can have these functions be in Python. Right. And then I should be able to go over to grid. I guess this step envs thing causes a problem, huh? Because basically what I would like to do, right, is I would like to do like int num finished float some episode reward, right? And then I would like to just go it's not in reset. I'd like step this. Yeah, this is what it was. I just didn't want to add like more structure into the C code. The int done equals this. And then we'll just do if done episode, where is it? Episode return. Yeah, it's funny. I immediately feel better. I literally just hadn't had anything to eat. This is what you want. And then we'll be able to get these variables from Python. Okay. Now this env just needs to have episode return. This tick float episode return. Tick. Episode return goes to 0. And then when you step, this should be bool step. We're going to ignore the fact that it is single agent for now. We're going to do bool done is false. Done is true. This. Return done. We also have to add the tick plus equals 1 if tick. This. There we go. So now we should have the thing that we want here. We no longer need all these functions. I think we'll leave them for now just in case. But this should be substantially easier. And then the way that this is going to look, right, is we're going to have report interval. Report interval is going to be 128. And then we're going to say report interval if report interval is equal to 0. You don't need episode return. Like this. Let's figure out what we have to fix in order to make this work. Cannot convert. Really? Step. Env has no attribute episode return. Okay. Well, it does, but I didn't add it to the struct, I believe. Right here. Assign, and then the signature changed. This is now a bint. And now this compiles. I think we also need to change we need to add the tick, right? This is self.tick. but this is going to log very infrequently. Not that bad. And then, of course, this is getting zeros. So what we're going to do is we're going to make this be something that is way easier temporarily. So this is spawn y is going to be 7 plus vision. Spawn x is going to be 9 plus vision. Going to be goal. So essentially, it's right. So essentially, I'm just trying to make this a really easy task to see if we actually get the logs in our learning. Looks like it. Maybe we have some crazy hyperparameters, right? I think we have some crazy hypers. Yeah, we don't need this to be this ridiculous. So what, we have 4096. Mini batch can be like 9.2. The batch size does have to be insane though, doesn't it? With 4096 ounce like this. Not really. You can just do 4096 times 16. What's that? Oh, duh. So we'll do 65K. And we'll basically just see if this does anything. Interesting that it goes to 1 immediately. And it backs off. Possibly rewards not getting set correctly. Some. Orange. Oops. Some. 0. Try this. I just want to see if we're actually getting any rewards. Oh, we are. And then it crashes. Oh, of course it does, because when you reset the environment, right, doesn't reset properly. Yeah, we never did proper resets. Mm-hmm. What's the intuition between how you're modifying your HPs, hyperparams, like batch size, learning rate? Are there general rules that you're following before carbs? Yeah, so what I'm doing at the moment, mini batch size is going to be at least 4096. That is for hardware because it's basically free to increase it up to that size with networks that small. And then in order to get at least like 16 backprop through time horizon, which is really on the low end, it should really be much higher than that. Multiply by 16 to get 65k. And then I deleted all the other carbs params because they were for different environments. So like they had some like crazy settings. So it's just using the defaults for the rest of them. But mainly it's just the get your reasonable hardware optimized ones. The issue at the moment is not hyperparams. The issue at the moment is me not resetting the M's correctly. Definitely that. Got it. Thanks. Yeah. So all I'm trying to do now is get like relatively efficient resets. This is super hacky, right? But I just really want to see this environment get solved today, and then we can worry about everything else after. Oh yeah, right here. Oh, error. Heh. That's funny. Grid address empty failed. Okay. Very obnoxious. I see the problem here, but I don't like it. We could always just do this. Still no? Really? Oh yeah, because you have... Really? Test multiple M's. Reset locked room env. Allocate locked room env. And then reset locked room env. Is this actually building correctly? That seems very weird. Yeah. It's building correctly. What? I'm literally setting it all to empty as well. the heck would be there? Oh wait, maybe this is not where it's failing. No, this literally it's failing right here. Even though I'm clearing the whole damn environment. Oh, is the agent just not getting set to the right? Yeah, it must be that the agent is not getting set to the right, hold on. Yeah, I'm being dumb. So you need this thing needs to go here. And now it works. Going up. Yeah. Look at that. This is the dummy test, recall. But yeah, now this solves it. It should. It should definitely solve it. So that's nice. Now what we're going to do is we're going to see if it ever gets the key. Okay? I think this is going to have to be substantially... What? Actually? How's that possible? That's kind of weird. There's nothing in here. Zero. Why is there nothing in the environment to see? Oh, because it didn't. That's file IO. That's obnoxious. C X. We need this annoying bit of code here. Here we go. So I don't know why it's like this, but like, you know, here's this guy doing things for some reason. Seems like he doesn't know how to go left. Is there an issue with going left? Possibly. Can I control him? I should be able to control him, no? No, I can't control him. Oh, because we have to add this to the... Well, if I do the C code, I should be able to control him, right? And then... set lock room. Env. Okay. Okay, here's the puffer. Something's definitely wrong with the action space. What happened here? Is it just not processing specific actions? This one processes. This one processes. They all process except for going west, I guess. North, south, east. Yeah, except for west. The heck? West is 4. Oh, I know. North. This is west. Okay, so this does work. I was gonna say, there's like no way, right? We go like this. Chomp. We ate the star. Done. 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 Reset block room. Cool. Let's just make sure this works. It's slightly difficult the way that I have it here. Because it's okay though. Look at that. It's kind of hard to do this. The controls at the moment need some improvement. Oops. Did it not let me get the key? Or did I just miss the key before? Oh, wait, I got the key and it just reset me. Here, let's just fix this so I can actually do this correctly. We make sure that I want to make sure that the env is reasonable before I try to make it do something harder. Cool. Interestingly, it's telling me that the key has been found on a lot of these guys. Why does it never go left? I assume the action space is wrong, right? Yeah, this is 5, not 4. Okay, so let's try this again. Okay, so you can see it says, because I have 4,000 of these running in the background, it says a few of them are finding the key already. So here's what we're gonna do. I didn't even think it would be that fast. So this is totally feasible then if it's actually gonna find stuff that fast. Interestingly, we don't have anybody unlocking the door. at all yet. Yeah, no door unlocks. Possibly we need to increase the horizon. $1,024. Give it some more time to figure this out. Finds the key so quickly. I mean, it's an exponentially deep search problem, right? Come on. Not even once. That's disappointing. Did it recompile? It did. Is the only way to do this to have like really long horizon? You know, like essentially unlimited horizon. Maybe then it'll find it eventually. If it's gonna do Brownian motion, it should, right? Just wandering around randomly. Shouldn't be anything to be training on. Hmm. Why? I would think if you wander around the environment just randomly for that amount of time, you would solve it, no? Possibly the RL's doing something weird. Set the learning rate to 0. That's what happens. So it should just be wandering around randomly. Still no, huh? I mean, really? Hmm. How long do we think? Is there any way to get a calculation of how long it should take? How about has key? You can get like a has key or something. I just want to see how many of these have the key. It should go up over time, even without training, right? Just by random exploration. Just set up. .93 with the key. That should be going up over time. That should absolutely be going up over time. It should not be able to go down. Am I resetting more than expected? Oh yeah. Why are we resetting? The horizon is wrong here. Okay, this should do it. We should be able to at least see the keys go up. So 86 with the key. Door unlocked. Reward found. Reward found. Okay, envs solvable. Envs so easily solvable. See what I mean? It's always shitty infrastructure and dumb, like, annoying problems. It's never... I mean, this is like this is literally an exponentially deep search problem, and it's still gonna do it. Look at that, you see? They literally learned it. Saving agent paths. Saving every path made during training would slow things, right? As a method of seeing what agents are doing? As a means? No, I've done that before. I've done that before. It doesn't slow anything down. At least not if you want to do it, like, reasonably. It just takes a little infra. Here, what we're going to do is we're just going to do like this, crack. I mean, we have it done. Literally, I didn't run a hyperparameter sweep. I wrote the jankiest freaking code possible. Like, I've been, like, just doing stupid things all day, and it's still solved. It will be, at least, here. We need to, we'll have to refine this metric a little bit. Oh, I forgot to rebuild the environment. It's gonna be super slow. Hold on. Here, I'll rebuild this. I'm going to run the experiment. Yeah, but there you can go. See, it's 3. There we go. Here. I'll leave this here for a moment. I'm gonna go use the restroom. I'll be right back. And, RL's so hard, guys. Yeah, it's only hard when you write your M's in Python and have no data. Be right back. What is happening? So our metrics are weird is what's happening. I have no idea if this has solved the environment or not is the problem. I don't know, let's just do 50 mil. Now we don't need multi-processing, it'll be fun. I only made it like, 50 times faster. Maybe only like 25 times faster even than the standard training implementation. I mean, I could make it a few hundred times faster if I wanted to. The stuff is not that hard if you just make it fast. You don't have enough samples. It's that simple. Let's see if this policy, if we can actually load it and watch it do stuff. And then we'll take a break from this to solve tic-tac-toe to prove the other guy on Twitter wrong. Maybe we'll do that. I mean, if I just do that, I can probably make that fast enough in Python, right? I mean, that should just solve instantly. This would be easily a million with a little bit of optimization. I don't even know what policy this is running. I'm sure it doesn't make sense for what I'm doing. I think there's like a redundant conv or whatever because the view field is too small. Whatever though, right? Alright. This might not be the right policy. Hmm. 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 Some reward. Someone up here. Something happened. Oh, the value loss spiked. Something weird happened there. Limit this to 1024 maybe. See about this one. Bro needs some help, yeah. I mean, several of them solve the environment in training, so it's not... Once you have that, it's just a little bit of fiddling away from fixing. You can see they're still getting the key. Need to rebuild. Don't forget that. Yeah. Oh, something got it. It's figuring something out. Need some better metrics. It looks like it figured something out right here. Like, there are some weird spikes, but they're not huge. Like, this is only from 1.6 to 1.5. So it does line up. It lines up right with the reward there. Oh, here you have... This is what it should be. This return. I'm tempted to just optimize it a little bit and run a sweep. How much faster is this? I mean, it should just be faster on the main box, right? This is not even the fast box. Did this just do something different? Be nice to just solve this without needing to do a sweep, but it's funny how it oscillates like this. It's very weird. We probably just need to up the log interval. Let's do this. This should give us a more stable. It'd be more stable. It's every 4 million steps or whatever. Maybe 8. There we go. So what's happening with the 1 at the start is that only the environments where it does happen to find it are reporting in that early, I believe. We'll just run a sweep on it, so no big deal. I don't really want to take my old grid environment out until I have this one working properly, though. Maybe we'll make we'll like move this to a different branch or whatever, something, I don't know. That'll be easiest. Okay, this is more reasonable. You can see it's some tiny fraction of the environments that's actually getting the environment solved. Yeah, that's correct. There we go. Need this. Environment reward. Alright. Do 100 mil. Got anything for us? Not optimizing. Could just be params. One chill sweep, right? Are our boxes down? What's going on here? Do we have boxes down? Oh, this is still on. This is the MOBA here. What's going on with my box? Tail scale being weird? Oops. Oops, I had a thing to reply to here as well. Let me fix this tail scale first. This should be up. Yeah, it was just tail scale being weird. What is wrong with the network? What the fuck? I can't even... Oh, did it work? Why is it detached? The fuck happened here? Oh, I'm dumb. Just tired. I forgot track. Yeah, we're fine. And I'm sure that I just forgot. Now, there's something totally wrong with this network. What the hell is this? Taking way too long for basic stuff. There we go, 1.2 million steps per second. Is that fast enough? That fast enough, eh? Yeah, 1.1 mil, 1.2 mil. Yeah, okay. We didn't even optimize the nets for this remotely either. I think the upper end, if I optimize the CUDA stuff here, we could probably hit 1.5. Well, I mean, you can look at the GPU utilization, actually. According to that, we should be able to probably hit 3 mil if we really optimized it. Folks, do star the puffer. Helps me out a lot. Here we go. I'll put this in the chat. All the code is here. Star the puffer helps me out a lot. It's, where's our chart? It needs more stars. It's at 1036. He's hungry. So what we'll have here is this carb sweep. And hopefully this will give us something reasonable within the next, I don't know, several minutes. We'll see. $6:01. I want to do tic-tac-toe real quick. Just for the hell of it. Why not? I'm probably just fine in implementation, right? It's tic-tac-toe. 3x3. Space is a discrete of 9. 1. Actually, no, m's. Observations is going to be zeros. M's by 3x3. Don't need this. This. Excuse me. Just doing tic-tac-toe real quick. Because it should be easy. The observations double as the state, so that's kind of cool. I can see we already have the second run there. Here's a crazy idea for multi-agent RL. Brain. What? Multiple actor policy. Let me see. The heck is this? Okay. I'm confused what this gets you. What is the, what's the problem you're trying to solve here? Like D DPG, yeah, DDPG, but with 2 inputs. So are you basically trying to train a net to tell if one policy is better than the other? Upweights the good responses and downweights the... What you get is a pairwise comparison rather than pointwise. Is this standard in RLHF? This is the first I've heard of this. I mean, I don't do RLHF, so... Crazy not that it was... Yeah. When you say it gets you a pairwise comparison signal, like... Upweight good, downweight bad is just reward, isn't it? I'm confused. Here, I want to get this thing done real quick. This is just a really dumb little hack project. I just wanted to see if it's like, if it takes 10 minutes. This probably doesn't take 10 minutes because I'm kind of cooked for the time being, right? Also, if I do it in Python, it's just going to be so freaking slow. I could just do it in Python and not have to do bindings, but still, I think I'll leave this for now. I would like to do it, it would be funny. Well, maybe I can. Is there like a really dumb, simple... Like, I kind of just want a hash table. Octo table. Has anybody just dumped the hash table? No, this is garbage code. Why are there 4 parts of this dumb project? Come on. No, this can't be done in Python simply. It's actually easier in... This is literally easier in C. Because I can just interpret the, It doesn't fit in a byte is obnoxious because it's 9 cells, not 8. Yeah, this would be cool to do today, but I don't think I've got the gas left. I do want to make sure that we're on a good track for the other stuff, though, so let me see here. Okay, so this is gonna run. We'll see if this solves something. Would be nice. You see the parameters on this? Still crazy value function stuff going on here. Mm. The value function and clip fraction are insane on this. See here? Hmm. Discouraging that none of these have decent curves on them. I guess in the meantime, the last thing I really want to do today is I want to think about how I can make there just be less binding code on all this stuff. I'm going to finish this cookie, and then I'm going to talk through my thoughts, and then I'll call it a day. So the key issue at the moment, it's essentially the source of the problem is also the source of the way that we make stuff so fast. When you make the environments from Python, you pass in a bunch of memory buffers into the environment. You have to pass in a bunch of these memory buffers. And this blows up the type signature of all the methods. And then when you bind to Python, you need to redeclare everything. Because the logs happen in Python as well. Python C barrier is just kind of tough. I mean, the main thing is I need a nice way to pull logging data out of these environments, right? I can't just keep pushing all the stuff into C because the problem is that I need to be able to extract logs from individual environments. And if I do the loop in C, that makes that portion harder. Right? I don't ever want to loop over the agents in Python. The way I did it for this little grid environment's actually not bad. You put the loops into the Python, and then since you have all the M's there, I don't like having this M star star though. I don't ever want to loop over anything in Python, yeah. I mean, I think you've probably, if you've been seeing me dev, you kind of see what I'm talking about, right? Like, so look, if I just open up, like, grid.py, this isn't very bad. This is 100 lines of code, and honestly, most of this is just the API stuff. We don't even need these constants anymore. Like these are redundant, right? So really I can delete these. 80 lines of code. And most of this, again, like all this stuff in here is just API stuff, so it's going to be even shorter. Like this, it's basically going to be a nothing file, right? The only reason we even really have it is so all these properties and such are exposed. Technically, it could just be a Python thing, right? We could just have this be Python. I don't think that makes sense though, because like there's some gymnasium bullshit that has to go on here, so I think you do need a little wrapper. But then what happens, right? Because of this, oops. Look at this, 130 lines of garbage. Basically doesn't even do anything. It's just this like giant redundant header. We shouldn't have to have any of this here, right? Because you have to pass these observations, actions, rewards, and stuff. And then it seems like this is the place that we'd have to do. I don't want there to be any logic in here. If we have to have this as a binding layer, like it should be purely a binding layer. But I don't want to have like a multi-env object or some bullshit. Writing everything to have internal vectorization technically fixes it, but it also makes everything more obnoxious and complicated. And I think what solves this problem. It's very obnoxious that I have to have a version that allocates its own memory and a version that takes already allocated buffers. That's pretty obnoxious. The damn type signatures are so long, right? I think at least I think Python supports default arguments at the very least. But that does that even help me? It really doesn't, because the defaults have to be in Python anyways, right? I'm not entirely sure with this. I'm gonna have to do some thinking. I'm gonna have to do some thinking. I'm starting to really feel the little bit of burnout on this project. You know, the days keep getting shorter and such. Um, I'm definitely gonna have to take like a mental reset at some point soon. Because I want to keep pushing on this. I'd love to keep working on this all night, but my brain's just gonna say no. Yeah. I guess I can at least go through the plan then for the next few days, right? Um, clean this up, get this environment learning, make like some reasonable number of specs or something, have a few different versions. Maybe we just do a handful of them. Put those online on Puffer GG. Definitely been there, take some time. Yeah, I don't know. I like the project a lot, right? I like the work a lot. It's just mentally kind of just burnt. The thing is it could be multiple things as well, right? I I did like a really good 2 month block of work. Uh but like I swapped my exercise routine after that, and I'm going back to getting heavier lifts in. And I just know that whenever I have to ramp back up to heavy lifts, it like just, I swear, it burns me out, like burns my neurons for a few weeks or something until I get used to it again. So I figured if I put it in the evening, maybe that would help, but it hasn't. I don't know. I gotta optimize a couple things. Still though, I can see where all this is going, and it's going in the right direction. It's just taking a little bit longer than I would like is all. I mean, the MOBA basically all we need to do is improve the visuals and like do a little bit of work on getting good trained policies. It should be pretty set from there. The side project that is unannounced is in a good spot. It's just gonna take, like, I gotta write some shaders, do some perf optimization, and port a couple of the missing features. It's hard, but like I know how to do it. I just need to be fresh for that. And then this thing here, this was just me wanting to port the grid environment and like upgrade it at the same time. I probably got a little carried away with it, but I mean it'll be nice if it can be used for this. Yeah. I think from here I'll step back on the custom stuff just a little bit since it's taking so long per environment. I'll probably see if I can get a couple bindings working for some existing envs. They're just not fast enough is the one thing that's obnoxious. I mean, I could go for like Doom. I've been wanting to do that one for a while. That's 100k FPS. I think it's 100k FPS without frame skip. That might be rough. The one thing that's a little bit annoying to me about the more complex environments I've been working on, the MOBA, and this is true of the other one as well, it's kind of hard to treat them as just like a standalone benchmark because they're competitive games. You need elo, and we have elo, but elo is, it's a trickier to evaluate metric than just like score or whatever. I really like the multi-agent environments, but the only ones that are easy to evaluate are the ones that are purely cooperative. The adversarial ones are much harder. So there's definitely like and we have the evaluation solution, we have elo, but it's still kind of unsatisfying because you always have to evaluate elo, and it's always going to be non-trivial. There's never going to be a non-trivial way. I mean, there's never going to be a fully trivial way to evaluate elo. It just always involves loading up multiple neural networks and such and running them against each other. So, I mean, like, really the key thing with Puffer, it requires that I keep building out this suite of more complex and interesting environments, and we have them, but they need to be easy to evaluate. If you ever need for better rating systems, I may be able to contribute. Well, I mean, hear me out here, right? Like, the issue isn't so much the rating systems themselves as much as like fundamentally, right? If you're training in an environment that is in any way adversarial, then part of the difficulty of the environment is going to be how good your opponents are, which means that your skill or your reward is relative. And as soon as that happens, that means that you can no longer just like run your policy on the environment to evaluate and be done, right? You have to load up multiple different policies, maybe even just a baseline policy, and you have to get like win rate versus baseline. It just makes the process harder, right? It's more of a logistical challenge than anything. Like we have it with the MOBA. It works. But it's still like it's adding an extra step to what is already a complicated area of research. I mean, I guess technically if I made like fast enough, if I made like some fast little C policies or something, we could embed the network as part of the environment, so you could have like easy, medium, and hard bot opponents or something like that that are just built in. I've seen that done before. That's hard, but it's doable. Maybe that's the way. Mm. I could definitely see that. I wonder how fast you can run. The thing is, the network forward passes are going to cut down a lot on the. They're going to really be expensive on the compute. Which leads us back to the original problem of this environment having to be fast enough. At the same time, it's like You really need that. You need the environments to be able to be multi-agent at the same time. It's like fundamentally an important learning dynamic. You can't just make everything single agent and hope for the best. It could just be a case of we just make the evals as nice as we can possibly make them. Right? We make like the ELO evaluation code as nice as we can possibly make them. We have some set of baselines that you can evaluate against, and that is what it is. It adds an extra step, but we make it as minimal as possible. That's probably the simplest way to do it. So like, let's say that we release, the capstone or so for this project is we release the agents, we release the environment, we make it nice and easy to evaluate against them. You just give a PyTorch model, right? It could work. Yeah. It's not that bad. With the board games, they used MCTS agents for a lot of them. I think that's what they did. As the opponents, I mean. Which I've seen before it works, but it slows the environment down massively. Alright. Well, I mean, that's enough musing. I'm gonna check the experiments and call it, because I should just go get some exercise, get some food, and go to bed. I'm trying to get to bed earlier, so I can get up earlier. Be back on this stuff. Oh. Oh, this might be something. Looks like this one was starting to go up. We'll see. We will see for sure. I will leave this one going overnight. This one is still running as well. This carb sweep is still running. And where's the sweep? I hope it's still running, right? Yeah. We'll see if this does any better. Some of these metrics, they look pretty good already. Alright then. I'm gonna call it a day. Night, everyone.